Let's understand how to find the square root of a square number through prime factorization. We have a natural number 6 and we know that the square of 6 is 36. Now, if you try to find out the prime factorization of 6, then you get, this is 6, so divide by 2, you get 3 here, and then this is 3. So you can write it as 2 times 3 in the terms of its prime factors. 2 and 3 are prime factors here. Now, this is 36. If you find out the prime factorization of 36, then you get, first you divide by 2, you get 18. Then you divide by again 2, you get 9. Then by 3, you get 3. And then again by 3, you get 1. So this can be written as 2 times 2 times 3 times 3 in the terms of its prime factors, the product of its prime factors. Now, if you notice, in 6 we have 2 prime factors, 2 and 3, and also in 36 also we have 2 prime factors, that are 2 and 3. But there is a difference. Since 36 is the square of 6, therefore if you notice, actually the prime factors are in pairs. That is, the prime factor 2 is twice the number of 2's we have here, and the prime factor 3 is twice the number of 3's we have here, right? So 2 is 2 times what we have in 6, and 3 is also 2 times what we have in 6, right? So let's take another number. We have 8 and 64, because there is some commonality in that. Using that, we'll find a square root. This is 8, this is 64. Find out the prime factorization of this. You get 2 divided by 4, then 2, then finally 2, you get 1. So 2 times 2 times 2. If we do this for 64, you get 32, then 16, you get 8, you get 4, you get 2, and you get 1. So here you can write it as 1, 2, 3, 4, 5, 6. So 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. Again, the number of 2's, that the prime factor 2 is here 3, the count is 3. Here you have 6. It means that it's twice of what we have in the case of 8, right? And we can make pairs. This is one pair, this is another pair, and this is another pair. Okay, now let's take, this is the last number, 12 and 144. Find out the prime factors of this one. So you get 2 times 6 is 12, and 2 times 3, and you divide by 3, you get 1. So you can write it as 2 times 2 times 3. Okay. Now tell me, without finding a prime factorization of this, what should be here in the case of 144? So the answer should be that we'll have twice the number of 2's what we have here in case of 144. So we have 2 2's here. It means that we should have 4 2's in the case of 144, right? Since we have 1 3 here, therefore we should have 2 3's here in the case of 144. Let's check it out whether it's correct or not. So 2, 7, 14 and 2, then you get 36, you get 18, you get 9, you get then 3, and you get then 3. So 1, 2, 3 and 4, 4 2's and 2 3's here. Now, and we can make pairs actually. This is in pairs. So let's go back to the first example. Can we say that if we have to find out the square root of 36, let's say we were not knowing that what is the square root of 36, then take 1 2 from here, then multiplied by, then 1 3 from here. That is 2 times 3, that's exactly the same to this one, that is 6. 6 is the square root of 36. In this case, take 1 2 from here, take another 2 from here, and take another 2 from here. It means that 2 times 2 times 2 exactly similar to this one, exactly the same to this one. It means that 8 is the square root of 64. In this case, you have, if you take 1 2 from here, another 2 from this one, and 1 3 from here, it's exactly the same to this one. It means that 2 times 2 is 4 times 3 is 12 is the square root of 144. Right. Now let's use this method to find out the square root of 324 and 256. Right. So let's begin. This is goes divided by 2, so 162, then 81, then you get 327, and you get 9, 3, then 1. So you have 2 times 2 times 3 times 3 times 3 times 3. This is one pair, another pair, and another pair. So 2 from here, 1 3 from here, and another 3 from this pair. So 2 times 3 is 6 times 3 is 18. 18 is the square root of 324. Let's check for this 256. So 2, 1, and 128, 64, 32, 16, 8, 4, 2, so 1 2 3 4 5 6 7 and 8. 1 2 3 4 5 6 7 and 8. This is one pair, another pair, another pair, and another pair. So 1 2 from here, another 2 from this one, another 2 from this one, and another 2 from this one. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 is the square root of 256. Okay, now we have discussed here how to find the square root of a square number using the prime factorization method. The same method can be used to check whether a number is the given number is a square number or not. So we have 48 here. Let's check whether this 48 is a square number or not. So if you try to find out the prime factorization of this, you get 24, and then 12, 6, 3, and you get 1. So 1 2 3 4, 1 2 3 and 4. Then you have times 3. Clearly you have this pair and this pair, right? The twos are, since we have 4 twos, therefore yes, we can make 2 pairs of 2, but in this case we have only 1 3, therefore this is not in pair. That tells us that 48 is not a square number. Okay, now this is 50, and let's check whether this is a square number or not. So 25, 5, and then 5. So we have 2 times 5 times 5. Here we have since we have 2 5s, so this 5 is in pair, but 2 is not in pair. That is why, since this is not in pair, and for a square number, when you do the prime factorization, the prime factors should be in pair. If they are not in pair, it means that that number is not a square number. Therefore 50 is not a square number. So let's say if it is asked to you that what minimum number should we multiply this 48 with, again I'm repeating, what is the smallest number or the minimum number that should be multiplied to 48 in order to make it a square number. So if you think here, if you look at this prime factorization, if we make this 3 in pair, that is if we multiply this number with 3, then we'll get actually a square number, because now we have this number is in pair. It means that if you multiply this 48 by 3, right, so this number will become a square number. But what's the new number now? The new number is 3 times 8 is 24 and 2, you have 144. Okay, you have 144 here. This means, it means that if you multiply this prime factorization with 3, then it's becoming a square number, but now the square number is actually 144. So this is the minimum multiple, this is the smallest multiple of 48 that will become a square number if you multiply this with 3, right? Same thing here. If someone asks you that if 50 is not a square number, then what number should we multiply this prime factorization, this one, with, so that this new number becomes a square number? Clearly, if you multiply with 2, then this 2 is actually now in pair. That means the new number is actually 50 times 2, that is 100. So basically what's 100? 100 is a multiple of 50, right? 50 times 2 means 100. 100 is a multiple of 50. This is the smallest multiple of 50, that is a square number. Here what's 144? 144 is the multiple of 48. 48 times 1 is 48, 48 times 2 is 96, 48 times 3 is 144. This 144 is a multiple of 48. But what's, the specialty in these two multiples? This is the smallest multiple of 48, that is a square number. And how did we find this? Using this one method. And same thing here, 100 is the smallest multiple of 50, that is a square number. We'll solve some more problems based on this topic in the coming video tutorials.